Hello everyone, I am Ram Mohammed Umar presenting my work Real Image Super Resolution using GAN through modeling of LR and HR process with co-author Christian McNally from the University of Udine, Italy. The goal of single image super resolution is to recover the high resolution image from its low resolution counterpart. The low resolution image is small, blurred and noisy, while the SR image is large and sharp image details. Simply enlarging the image by traditional interpolation methods like bicubic, bilinear, and nearest neighbor fail to recover the sharp image detail. Usually the low resolution image degradation process is followed by the following image observation model, where the blurred kernel is convolved with the latent HR image, then bicubic downsampling operator is applied to reduce the image size. After that, the white Gaussian noise is added into the image. Further, the JPEG compression is applied to the whole process. Then we get the LR image. The most SR approaches such as ESR GAN assume an ideal bicubic downsampling kernel, which is different from the real degradation. The synthetic degradations overlap small portion of the real degradations, where the real degradation space is much bigger than the synthetic one. Therefore, the existing SR approaches have limited performance for the complex degradation in the real world SR task. The real complex degradation usually come from the complicated combination of the different degradation processes such as the imaging system of the camera, image editing and internet transmission. For example, when we take a photo from the smartphone cameras, it goes into the multiple degradations of the camera system like the camera blur, the sensor noise, the sharpening artifacts and JPEG compression. Further, it goes into the online or offline image editing tools and then it uploaded to the social media with further compression and unpredictable noises. Lastly, it's shared to the several times on the internet. The whole complicated process makes the real SR problem more complex in the real world setting. So this motivates us to model the L and LHR process in an end-to-end manner by implicitly learning the downsampling and upsampling process. The representative diagram of our proposed real SR approach is shown here, where in the LR learning stage, the downsampling network GSR takes the HR image and generates the fake LR image by learning the real corruptions with the supervision of the discriminative network DY. We train the GLR network by the given generator loss functions. After that, we synthesize the paired L and HR data to train the generalized SR model with the following SR generator loss function. Moreover, we use the modified resonance structure in the both LR and GLR and GSR networks where the continuous and differentiable periodic nonlinearities like the sign layer are used that are capable of representing complex and fine details of the complex signals than the standard common nonlinearities like ReLU. We refer to our paper with more details of the sign layer. So for the quantitative result comparison, we shown the 4x upscaling SR results on the DVI2K validation set. The upper portion of the tables, we compare our approach with the synthetic degradation like sensor noise with given sigma 8. We achieve better PSNR SSI value while comparable LPIPS value as well. Similarly, comparison is done with the JPEG compression degradation in the middle section of the table. In the bottom section, we compare our method with the unknown corruptions in the real world super resolution challenge series validation set. We achieve better performance in terms of PSNR SSN and comparable LPIPS value. We also do the evaluation study of the different paired L and LHR data to train the SR model and shown that our generated paired L and LHR data is better to enhance the performance of the SR network. So for the VIA result comparisons, we shown the 4x SR result comparison on the DVI2K validation set. Our method achieves the comparable visual quality with the other existing approaches with almost no visible corruption there. So we conclude our presentation with the following remarks. The proposed approach solves the real SR problem by implicitly modeling the LR and HR process with incorporating the sinusoidal nonlinearities in the HR and LR model to better represent the underlying complex signals. We first synthesize the paired realistic LR and HR training data with the LR generator network instead of the traditional existing synthetic data generation techniques. Thus, we use this paired LR and HR data to train the more generalized SR model to super resolve the LR images. Our method achieves better SR results in terms of PSN and SSIM values and comparable LPIPS values as well. And we have also the good visual quality compared to the other existing methods. Thank you for watching.